Hello students, warm welcome to all of you at AriserTalent. I'm your chemistry teacher and I'm on the chapter of class 10th chemistry, that we are on the chapter number 1st, that is chemical reactions and equation. So what we have discussed until now is, in our previous lecture we have discussed about the oxidation number. So what basically the oxidation number is? Oxidation number is a charge on a particular ion in its ionic form when all the other atoms are removed from it. Then we have discussed the rules for writing the oxidation number. Now we will apply these rules in our today's lecture and try to find out the oxidation number of different elements. So we have different elements and we will try to calculate the oxidation number of these elements. So our today's topic is calculation of oxidation number. So in our today's lecture we are going to discuss about the calculation of the oxidation number. So for this calculation we have considered different elements here. So our first element is H2S, that is hydrogen disulfide. Then we will consider our second element. Our second element is H2SO4. Then we have our third element. Our third element is NH2SO4. Our third element will be C6H12O6. Then we are our fourth element. Our fourth element is, the fourth elements I am considering here is BF3, that is barium fluoride. Then we have our fifth element. Our fifth element is carbon monoxide. Now we are on our sixth element. Our sixth element will be FeCN6 raised to the power plus 4. Now our next element is element number 7, and the seventh element will be in this series. We have BrF3. Here we have taken BF3, that is boron fluoride, and here we have taken BrF3 negative, that is fluoride ion. Now we will consider these different cases and try to find out the oxidation number of all these elements. But for which element we have to find the oxidation state, I am underlining that particular element for which we have to find the oxidation number. So in this sequence we have to find the oxidation number of sulfur. Here also sulfur. Then here we have to find the oxidation number of, let us suppose, carbon. In BF3 we are assuming that we have to find the oxidation number of boron. In carbon monoxide we have to find the oxidation number of carbon. In FeCN6 we have to find the oxidation number of iron. And last, BrF3 negative, we have to find the oxidation number of Br. So now we will try to find out the oxidation number of all these elements. But what we have to do before this is, we have to write some important rules or steps for calculating the oxidation number of the element. So I am finding the oxidation number of sulfur in H2S. So what I will do, in our step number 1, we will write the formula of that compound. The formula of that compound is H2S. Now, in our step number 2, what we will do? In our step number 2, we will write the charges among these elements as given as according to the periodic table we have learned. But the unknown quantity which we have to measure, we will consider this as a X. So here we have H2 and S. So For sulfur, I have to find the oxidation state, so I am writing here X, and for hydrogen, I know its oxidation state will be +1. That will be the some of the important table that we have to learn the oxidation state of some elements to find the oxidation state of other elements. Now what we will do here in step number 3, we will calculate the oxidation state of this. So our step number 3 will be H2. We have the 2 molecules of hydrogen here. So what I will do here, 2 into 1 plus X we have to calculate, and in equal to we will write 0. Now on solving this equation, what I am getting here is 2 plus X is equal to 0. X is equal to -2. It means X equal to -2 will be the oxidation state of sulfur in case of hydrogen sulfide. So the oxidation state of sulfur will be -2. So this will be the answer of this question. Now proceeding to our next element, we have to calculate the oxidation number or oxidation state of sulfur in case of sulfuric acid. Now we will follow the similar steps and try to find out the oxidation state of these elements. So again we have step number 1. We will write the individual elements over here, H2, S and O4. This is our step number 1. In step number 2, what I am doing here is I am writing the oxidation state of the element which I have known. So for hydrogen, the oxidation state will be +1. For sulfur, I have to calculate the oxidation state, that will be the X. So in this sequence, we have to find the oxidation number of sulfur in case of sulfuric acid. So in step number 1, I have write the individual elements over here. Then we know that for hydrogen, the oxidation number will be +1. For sulfur, we have to count the oxidation number. So we are assuming it as a X. Now what we will do here, we are provided with oxygen 4 molecules and the oxidation state of oxygen will be -2. Now what we will do in our step number 3, I will write 2 into 1 plus X I have to be calculated, 4 molecules of oxygen multiplied by its oxidation state, and it must be equal to 0. Now on solving this equation, we will get 2 plus X minus 8 equal to 0, X minus 6 equal to 0, and we are getting X equal to 6 after substitution. So X equal to 6 will be the oxidation state of sulfur in case of sulfuric acid. I hope this equation will be clear to you that how transposition will be done in case of these equation. Okay students, now we are proceeding to our third element. This is C6H12O6. This is the basic formula for glucose, and I have to calculate the oxidation state of carbon in case of the glucose. So what we will do, I will do here, I will follow the similar steps. Again, our step number 1 is writing the individual elements. Now what we will do in our step number 2? In our step number 2, C6, I will assume it X, H12, we are provided with +1, and O6, that is equal to -2. Now, in our step number 3, we are going to solve this equation, and what we will get here, 6 into X plus 12 into 1 plus 6 into -2 will be equal to 0. So on solving this equation, what we will get here, 6x plus 12 minus 12 equal to 0. So what we will observe here, plus 12 will be cancelled by -12 and 6x equal to 0. It means x equal to 0. So x equal to 0 will be the oxidation state of carbon in case of glucose. So the correct answer is x equal to 0. These are basically the oxidation states we have calculated for the unknown element. Now we are proceeding to our next element, that is BF3. Now what we will do in this case, we will write in our step number 1, we will write the individual element. In our step number 2, what we will do, we have to calculate the oxidation state of boron. So I am assuming it X. F3 will be in the -1 state. Now in the third step, we will do our calculation, that is X plus 3 into -1 will give 0. So why I have multiplied 3 with -1, this is the reason behind that will be, we have provided with 3 molecules of fluorine. So we have to multiply 3 with -1 because the oxidation state of fluorine will be -1. So we will get X minus 3 equal to 0, and in our last step we will get X equal to 3, that is equal to plus 3. It means oxidation state of boron in case of boron fluoride will be plus 3. Okay students, now I am proceeding to my next element. Our next element is CO. CO here is carbon monoxide. So again we are repeating the following steps now. We will write the individual elements over here. In our next step, I have to calculate the oxidation state of carbon. So I am substituting it X. For oxygen, we have the oxidation state that is equal to -2. Now what we will do in our third step, X minus 2 equal to 0, X is equal to plus 2. It means oxidation state of carbon in case of carbon monoxide will be plus 2. So the plus 2 will be the correct answer here. Now I am proceeding to my next element. The next element we have provided is FeCN6. It means it is ferrous cyanide. Now what we will do, we will follow the similar steps here. In step number 1, I am writing Fe here and Cn here, Cn6. Now what we will do in our next step, we are considering Fe as a X, and we know that cyanide is having a charge of -6 on it. It means cyanide is having an oxidation state of -1. Now what we will do here, we will write X for Fe plus 6 multiplied by -1. X is for Fe and we are provided with 6 cyanide molecules. So we are multiplying 6 by -1 and it is equal to plus 4. So students, why I am substituting plus 4 in the RHS side of the equation? Because the total charge on that compound is plus 4. If the charge is not given, we will substitute it equal to 0. So X minus 6 equal to 4. X is equal to 6 plus 4, and what we will get here, X equal to 10. So X equal to 10 will be the oxidation state of iron in case of ferrous cyanide. Now we are proceeding to our next component, that is BrF3. BrF3 is basically the bromine fluoride. Now what will happen in this case, we will follow the similar steps over here. So our step number 1 is, we will write the individual element for it. As we have written Br and F3, now we will write the oxidation state of a known element we have provided. So what I am doing here is Br, X, and for fluorine I know the oxidation state is -1 as we have seen it from the oxidation number table. Now what we will do here, X plus 3 into -1 will be equal to 0. Now I am substituting 0 in the RHS of the equation because the total charge on that compound will be equal to 0. So what we are getting here, X minus 3 equal to 0, X equal to 3. It means X equal to 3 will be the oxidation state of bromine in case of this fluoride ion. So students, here we have discussed the oxidation number of different elements. Here I am describing the 7 components here. Now we will deal with many more components, but before, if you want to copy it from here, please copy it now. So students, these are the basic oxidation state of some of the elements here. The concept oxidation number will not be only up to class 10th, it will be important for class 12th also, because you have to balance the equation according to the ionic number concept or oxidation number concept. So this topic is very important from your exam point of view, as well as from certain competitive exams like NTSE and Olympiads also. But now before proceeding to our next question, we have a bit correction here, that is FeCN6 will be provided in -4 state. So FeCN6 will be in -4 state. What we will do, we will substitute -4 over here. This will be -4, this will be again -4, and what we will get here, (6 minus 4), then X is equal to 2. It means in case of the cyanide ions, the oxidation number of iron will be 2. So 2 will be the correct answer. Now we are proceeding to our next category of the elements, so the oxidation number concept will be clear to you. Now proceeding to our next category, we have again different elements. Now we will consider many more elements for understanding the oxidation number concept. So again we have a variety of elements. So the first element I am considering here is NH4 whole twice SO4. Second component we have chlorate ion. Third element I have ClO3 negative with a different valency state. Fourth element we have hydrogen carbonate. Fifth element we have carbon dioxide. Sixth element we have CuNH3 H2O twice raised to the power +2. This is the coordinate compound of the copper and ammonia. Now we are on our next element. Element number 7. For element number 7 we have Cr2O7 - 2, that is chromate ion. And lastly we are taking our ninth element as Na2SO4. So again we have a variety of components here, and we have to calculate the oxidation number of these elements. So before proceeding to the oxidation state, I am underlining the component for which I have to find the oxidation state. So here we have to find the oxidation state of sulfur, here chlorine, here again chlorine. In this case we have to find the oxidation number of carbon, again carbon. In this case we have to find the oxidation number of copper ion. In this case we have to find the oxidation number of chromium ion, and in this case we have to find the oxidation number of sulfur. Now we will follow again the similar steps that we have followed in the previous questions and try to find the oxidation state of the following elements. Now again we have our step number 1. Our step number 1 is we will write the individual elements in the step number 1. So the individual elements are NH4 whole twice, S and O4. What we will do in our step number 2? We will write the oxidation number of the known elements. For having a ammonia is having an oxidation state of 0. For sulfur it is X, and for oxygen it will be -2. Now, in our step number 3, we are trying to find out the oxidation state of the sulfur. So, what we will do here, 2 multiplied by 0 plus x plus 4 into minus 2 equal to 0. So, 0 plus x minus 8 equal to 0. So, x will be equal to 8. It means oxidation state of sulfur in case of ammonium sulfate will be plus 8. Now, I hope this must be clear to you, and I am proceeding to my next element. Then I am following the similar steps over here. We will write chlorine here, O4 here. Now what we will do? We have to calculate the oxidation state of chlorine. So above chlorine I am writing X, and for oxygen we have the oxidation state of -2. Now what we will do in our third step, X plus 4 into -2, but that will be not equal to 0. This will be equal to the total charge on that component. So the total charge is -1 here. X minus 8 equal to -1. X is equal to 8 minus 1. X is equal to 7. So the 7 will be the oxidation number in case of ClO4 negative. Okay students, I hope this must be clear to you. So I am proceeding to my next element. Our next element is ClO3 negative. Following the similar steps, I am writing Cl here and O3 here. Now what we will do? We have to calculate the oxidation number of chlorine. So I am writing X here, and for oxygen it is -2. Now what we will do here? X plus 3 into -2. Should it be equal to 0? It won't be equal to 0 because the charge -1 is provided on its component. So it will be equal to -1. So X minus 6 is equal to -1. X is equal to 6 minus 1. X is equal to 5. So X equal to 5 will be the oxidation state in case of ClO3 negative ion. Now we are proceeding to our next element. Our next element is hydrogen carbonate. What you have seen here, it is provided with minus charge. So we will substitute -1 in the RHS side of the equation. So what we will do here, HCO3. In our second step, HCO3. H is +1, carbon X, and oxygen again is -2. Now we will do our simpler calculation. 1 plus X plus 3 into -2 will be equal to -1. Why I am multiplying the -2 with 3? Because the oxygen molecules we are provided here is 3. So 3 into -2. Again solving this equation, what we will get here? X minus 5 equal to -1. Because -6 plus 1 gives us -5. Now X is equal to 5 minus 1 and X is equal to 4. So X equal to 4 will be in case of CH hydrogen carbonate. So here oxidation state of carbon in case of hydrogen carbonate will be 4. Now we are on our next element. We are on our carbon dioxide. So again we have to calculate the oxidation state of the carbon. Following the similar steps, I will write C here and O2 here. Okay students, now carbon having X and oxygen having -2. Now what I will do here, I will write it as X plus 2 into -2, and that will be equal to 0. Why I am substituting 0 in this equation? Because the carbon dioxide is not provided with any charge upon it, so the right hand side must be equal to 0. So what we will get here, X minus 4 equal to 0, X equal to 4. So the carbon monoxide and carbon dioxide having a difference in their oxidation state. In case of carbon monoxide that I have discussed previously, having an oxidation state of +2, but in case of carbon dioxide what we have observed is the oxidation state changes into +4. So This is a basic rules for finding the oxidation state here. Now coming to our next element. The next element we are observing here is a bit complex element because it is a coordinate compound having copper, ammonia and H2O. So we will try to find out the oxidation number of this element following the similar steps. Our step number 1 is we will write the individual elements here. So individual elements are Cu, NH3, H2O. Now what we will do in our step number 2? In our step number 2, we will write the oxidation state of the known elements. So copper X, ammonia is provided with 4, 0, H2O is provided with 2 and it is having the 0 oxidation state. Now in step number 3, calculate the oxidation state of the following compound. What we will do here, it will give X 4 multiplied by 0. Why I am multiplying 4 with this compound? Because the oxidation state of ammonia is 0 and we are provided with 4 molecules of ammonia here. 2 into 0 equal to, the charge on this compound is plus 2, so I am substituting plus 2 here. So what we will get here, so the oxidation state of copper in case of this coordinate compound came out to be X equal to 2. So here the oxidation state will be plus 2. So the correct answer is here X equal to 2. I hope this must be clear to you by calculating the oxidation state by calculating the unknown quantity as a X. Now we are on our next element, Cr2O7 - 2. This is basically a chromate ion. Now we will follow the similar steps. First write chromium here, oxygen here, chromium here and oxygen is provided with 7 molecules. So chromium is having X and oxygen is having a charge of -2. Now what we will do here, X plus 7 into -2 will be equal to -2. I am putting -2 here because charge on that particular compound is -2. So we will get X minus 14 equal to -2. X is equal to 14 minus 2 and it came out to be X equal to 12. So in case of chromate ion, what we have see here, we are provided with 2 chromate ion. It means 2 chromium are here. So I have to multiply it by 2. Again here 2 and I have to write 2 over here. So we will get 2x equal to 12 and on substituting 2 over there, we will get 12 by 2 and 12 by 2 will be equal to 6. So in case of chromate ion, we will get oxidation state equal to 6. Why I am multiplying 2 over here? Because the chromium are provided with 2 molecules and oxygen is provided with 7 molecules here. Now coming to our next element, we have the last element in this series, that is sodium sulphate. So in case of the sodium sulphate, we will repeat the following steps. Na2 here, S here and O4 here. Na2, S, O4. Now sodium is considered in the category of alkali metal and alkali metal is having a charge of +1 on it. For sulfur we are assuming it X and for oxygen we know that the charge is -2. Now we will do 2 into 1 plus X, 4 into -2 will be equal to 0 because the compound which is present here does not carry a total charge upon it. So it will be equal to 0. 2 plus X minus 8 equal to 0. X minus 6 equal to 0 because 2 minus 8 will be -6 and X is equal to 6. So for sulfur, in case of sodium sulphate, the oxidation number came out to be 6. So I hope these oxidation states will be clear to you We have many more examples in this category, but all the question will follow the similar rules. So if you want to copy it, please copy it from here. So students, this lecture is over for today. Our today's lecture is all about the calculation of the oxidation state. We will deal with many more topics in our next session. So thank you so much and have a nice day.